All right, well, welcome back. Looks like I haven't scared you off with that previous dictionary conversation. So we'll go ahead and jump into sets. When we talk about sets, they are objects that are stores of collection of data in the same way as mathematical sets. If you're not sure what a mathematical set is, you may want to go Google that, take a look at that. But simply, they are nothing more than kind of like I said, mathematical sets. All items must be unique. A set can and usually is unordered, and elements can be of the different types. So keep that in mind when you're going forward with this. We can create a set. For an empty set, we just call the set with an empty set of parentheses, no argument in that set. For a non-empty set, we're going to call that set and give it an argument where the argument is an object that contains an iterable elements. So anything that can be iterable. It can be a list, a string, or a tuple. Now, if the argument is a string, then each character will become an item of that set. It's going to become a set element. So for set of strings, pass them to the function as a list. If the argument contains duplicates, only one of the duplicate will appear in the set. It will ignore the second or more so duplicate. Keep that in mind. You cannot have duplicates in your set. You can use the len function on a set to see how long or how many items, how many items are in your set. Sets are mutable objects, so you can change them. You can use the add method, just like we've used in previous sequences, and that is to add elements to a set. We can update items in a set, so adds a group of elements to a set, and that argument must be a sequence including iterable elements, just like we talked about before. You are able to delete elements from a set. The remove and discard methods will remove the specified items from the set. The item that should be removed is passed to both methods as an argument. They behave differently when specified item is not found in the set. The remove item will throw a key error exception if it does not find it. So again, you'd want to check to see if that item is in the set before you remove it, or you want to catch that key error if that's going to happen. Discard method does not raise an exception. It basically ignores the fact that you've given it an item that does not exist. Like with dictionaries, the clear method clears all the elements from a set. You can use a for loop to iterate over elements in a set. The in operator can be used to test whether items are in that set. So we were just talking about using that remove you want to test. Well, here you can. You can use the end or the not in to check to see if a value exists or does not exist in a set. Now, this is where sets get to be a little bit more unique on the reason why we might use them. So we can put the union of two sets, which is a set that contains all the elements of both sets. So a union essentially makes another set with all the items of the two sets. But remember, if uh, if there is an item or so in each set that is duplicate, it will only take in one of those items. You won't have a duplicate in your new union. Here's how you do that. You can say set one union and have set two as the parameter. You can also use this single pipe mark, this operator. It's a single pipe mark. That's usually for a lot of people above the slash key. It is called the pipe character. Both techniques return a new set which contains the union of both sets. We can also find the intersection of sets. Now, an intersection is a set that contains only the elements found in both sets. So essentially, it would be if set one has a certain set of items that also is in set two, then your new list would contain those items. Again, it only contain them once because it's not going to duplicate them, but that's the point of the intersection, is to give you what's in both sets as a new set. You can do this by using the intersection function off of one of the sets, passing the second set in as an operator as a part of an argument, And we can also use the ampersand sign, just one ampersand sign, to also intersect two sets. Both techniques will return new sets which contain the intersection of both sets. We can also find the difference of a set. So a difference of a set is a set that contains the elements that appear in the first set but not in the second set. Now this is important to understand, especially since when you do these particular methods, you can see that there is an order here. So we want to find it returns a set that contains the elements that appear in the first set but not appear in the second set. All right. So if it's in the first set but not in the second set, that will come out as your new set that's returned. This is the minus sign as the operator, or we can call this particular method. Find the symmetric difference of sets. Professor Waits, what's the difference between symmetric and just difference? Well, in a symmetric difference, you're going to get a list, or a set where the elements are not shared by the two sets. So simply, if something exists in set 1 but not set 2, it's going to be a part of your new set. And vice versa. If it's in set 2 but not in set 1, it also will be added to that. So all the items that are unique to each set, it's going to give you back the unique items that are in both sets. We can call the method, or we can use the caret operator. Now, we can find subsets in supersets. A subset, let's say it this way, that set A is subset of set B if all the elements in set A are included in set B. Now, this is a little backwards than what I would think of it as, right? So I typically say if all the items in set B are in set A, then set B is a subset of A. But they're just saying, hey, again, it depends on how you want to read it. If you want to say if all the items in set A are in set B, then set A is a subset of set B. So if we have A, B, C, D as our set B, and our set A has B and C in it, because B and C are in set B, then set A is a subset of set B. So if we want to determine whether set A is a subset of set B, we use is subset method. So we say, hey, is set A a subset of B? We can also use the less than or equal sign to do the same thing as a subset. So let's take and clean this up for just a second, just to do it one more time. If we have set A, and it's got A, 2, 3, C, and then we have set B. Gotta set B equals A and C, then set B, because it exists in set A, is a subset of set A. However, set A is not a subset of set B. It is not. And that's because it has 2 and 3 that's not in B. Now, if set A is a superset of set B, if it contains all the elements of set B, to determine whether set A is subset of, excuse me, to determine whether set A is superset of set B, we use the is superset method. So in this case, up here, let's write down here. I think it was C, wasn't it? Yeah. And then we've got what do we say? A and C. Yep. Then set A is a superset of set B because it has all of the items in set B. Even though it has additional items, it does have all the items in set B. So set A is a superset of set B. Set B is a subset of set A, and set A is a superset of set B. And I know you were just thinking to yourself, man, I really wish we can do comprehensions on sets. You can. Good news. You absolutely can. And I hope that you do. So we can use comprehensions on a set. It will return a set based on your comprehension. So a concise expression that creates a new set by iterating over the elements of a sequence. So again, we do comprehensions typically in place of for loops. A set comprehensions are written just like list comprehensions, except that a set comprehension is enclosed in curly brackets instead of square brackets. So like we did before with the dictionary, we're going to show you a comprehension where we copy a set. And so here we set up 1 as a set, and we call the set method. And we give it an iterative list by using the square brackets. So this turns into a list, and now it sets it as a set. And then here is our for statement. So for each item in set 1, it's going to iterate over that, take that item, and store it here, which we don't do anything to that item, so it's going to store it as the new set. So now we have a set 1 and a 2, both all with the same items in it. As we've done before, in this one, we're going to just create the squares of each item in set 1. So we have that for item in set 1, and then item goes here. We then square it, and that gets returned into our new set, which is 1, 4, 9, 16, and 25 based on the squares of each of these numbers. We can, like before, do an if in our comprehension. So here we have our for, we have our if, and then in this case, we aren't really doing anything with the item. So if it's less than 10, then we're going to go ahead and put it in that item, which then puts it in that item, which then stores it into this new set. That's why we have 1, 2, and 3, because the other numbers are greater than 10. All right. So that is all the information we have on sets. When you come back, we're going to take some of these items and we're going to serialize those objects. When we serialize objects, that is to allow us, for the most part, to write them to a file. We can also write them to other places. But in this chapter, we're going to be talking about writing to a file. We're going to talk about a fun term called pickling. I will also let you know what that is called in other languages. So I hope to see you real soon. All right.